I'm Stephanie Ling. My classmates and I have created this monthly science segment at the Bonita Museum and Cultural Center to explain some STEAM concepts, that is, science, technology, engineering, arts, and math, in an effort to make STEAM more accessible and fun for everyone to learn. We have two different types of videos, both of which you can access in our YouTube channel linked below. One type is the explanatory videos based solely on the exhibits within the museum, and the other is where we'll conduct easily replicable experiments for all ages. With that, let's head in for an explanation of the concepts that this video will cover, which include archaeology and the rich fossil history of Bonita and our surrounding areas.
So here we have a diorama made by Brian Gibson of the different eras we find fossils in. Specifically, the Pliocene era is when we have the most fossils in the Chile Vista region. For example, these fossils found right here were dug up and excavated by the Natural History Museum and donated to this museum. So right here, you'll see that we have the Albertosaurus, which, look it up, will look like the most generic dinosaur in existence that you've ever seen if you follow me over here. We also have the Mosasaurus, which is this big, giant, fish-like dinosaur that was obviously a predator, and I gotta say, if you're afraid of sharks, you'd not have a fun time at the beach with this boy around. This whole exhibit kind of just represents the wonders of paleontology, and if you come down here, we see the story of a paleontologist who is exploring the gemline mines around the area and comes across the ammonite and skeletal fossils. This portion of the exhibit kind of shows the environment in which fossils are found, like the rocks, minerals, and even in the soil.
This exhibit is full of history that is all around us. It aims to bring man-made and natural history to light so more can learn about it. Staying in tune with this, a fossil was recently discovered in Otay Mesa, San Diego. It is said to contain skeletal remains of extinct mammals, including camels, oreodons, Zespia, close relative to camels, rodents, and possibly large carnivores. Plant fossils and volcanic bombs, which are masses of rock ejected by volcano, had also been found. What makes this discovery especially interesting is that these fossils had been found in a geological formation in which we had little to no information about. After some time, it was discovered that these fossils were indeed found in the Miocene era, which is shown right here, including this Alodespis, which is a leopard seal-like animal. This demonstrates how we can learn from these fossils. For example, the Alodespis had these sharp teeth indicating that they hunted other seals. This means more research opportunities and a greater insight into the prehistoric San Diego area.
Hi everyone, I'm Matthew and this is my partner,
Roxanne.
and today we're going to be talking about evolution. Now, Roxanne, what exactly is evolution?
Evolution is the process in which living things can change over time.
Now, we can't necessarily see ourselves evolve, and that's because it takes thousands of millions of years. And through these years, we can realize that these organisms have adapted to their environment to better their survival.
An example of evolution is Darwin's finches. The great scientist Charles Darwin paved the way for evolution. He went on a voyage where he discovered a species of birds that are all relative to each other. He found that although the birds were the same species, they had key differences in their beaks. He discovered that birds with longer beaks had evolved to better eat cactus roots and avoid the spikes, but those with shorter beaks had evolved to better open nuts and eat bugs off the ground. This is an example of why evolution is important for species to thrive and survive in their environments.
Fun fact, birds are the closest relatives to dinosaurs. While humans are birds, we still go through change too. The most notable one being our brains. Our brains have gone bigger and bigger and bigger. Now, our increased brain size is the reason we live in this beautiful world today.
Coming up in the video, my friends will explain how people like you and me have used our great minds to come up with the wonderful knowledge we know today.
Hi, I'm Jordan. I'm here to talk to you about carbon dating. Carbon dating is basically a way to determine the age of fossils like these through the amount of carbon within any given fossil. But carbon is found everywhere in every living organism. So carbon dating is known as an absolute way of dating fossils because of how extremely accurate and precise it is. Carbon dating is done by measuring the amount of carbon-14 within a fossil. Carbon-14 itself is known as a radioactive atom, which means that over time it decays, in other words, that it doesn't stay carbon-14 forever. And every 5,730 years, the amount of carbon-14 within a fossil decreases by half. So scientists are then able to measure the amount of carbon-14 within a fossil and then calculate the exact date of when something died. And now here's Aiden and Miles to talk to you about the Cretaceous period.
Thanks, Dorian. My name is Aiden. Fossils are really important to understanding history of life as we know it. For example, humans and mammals have only been around for about 300,000 years. Now, let's go back into the Cretaceous era, which is almost 100 million years old. During the Cretaceous period, the world was covered in tropical paradise. Sea levels were rising up higher than you could ever imagine. New species and animals were created. For example, birds evolved during this time period as well as new flowering plants. This created tons of diversity across the globe. Forests were even spreading to places such as the Arctic. The entire globe was in this tropical climate. Now looking at this chart, as humans, we're up here on the topmost layer. Now, the Cretaceous period is all the way down here, and it has some of your favorite dinosaurs, like the mosasaur, the ankylosaur, and the albertosaurus. And now we have Miles.
Thank you, Aiden. Hi guys, my name is Miles. However, the Cretaceous era came to an abrupt end with the arrival of a massive asteroid that killed off all the dinosaurs on Earth, as well as 75% of all species on Earth. This event was known as the Cretaceous Paleogene Extinction event. Even though the Cretaceous era came to an abrupt end, it was filled with lots of lush sea life. One example is the weather vane scallop seen here. This is the largest scallop in the world and is a delicacy and still farmed today in Alaska. And some more examples of species during the Cretaceous era are the famous T-Rex, as well as a large sea snake called the Pachyrachus. However, all of these species are extinct today, as with the asteroid took all of them out.
Now that we've learned about fossils and evolution, let's discover a potential career path that relates to them. Wouldn't it be amazing to spend your day thinking about extinct species, dinosaurs, and fossils? People who study plant and animal fossils for a living are called paleontologists. But their work goes beyond the Jurassic Park and into our modern world. Especially in a time where climate change is increasing, this information is crucial to understand.
Similar to paleontologists, archaeologists use tools like shovels and brushes to uncover ancient buildings, weapons, art, and even money. This process is called excavation. It's like digging for treasure. But the real gold in this field is in the way archaeologists interpret and analyze these artifacts. Many prehistoric civilizations did not leave written records behind, so artifacts provide the only clue about an ancient civilization or community. Archaeologists study these artifacts to learn more about the people in the past, their culture, and how they lived. Dig into this field and become a detective of the past.
Thanks for tuning in to our video about the science of archaeology. Being exposed to STEAM is very useful for learning about our community, as it not only highlights our technological innovation, but also the way people have to collaborate in order to take part in these astonishing feats, which is what STEAM is all about. To learn more about STEAM, catch our next exciting video where we'll conduct a forensics experiment that you can easily replicate at home.